My name is Jim Staliano, and I am Principal Scientist at R-DEX Systems in Woodstock, Georgia. And today I am talking about how you can increase trust in artificial intelligence and improve robustness against adversarial attacks of your systems. Artificial intelligence, AI, is everywhere and seems to have superhuman performance in its specified tasks, like classification of objects. Of particular interest is using AI to reduce the cognitive load on analysts and warfighters. However, with these amazing AI abilities, there's a major shortcoming. AI is easily fooled. The process of fooling AI is called adversarial attack. As an example, a small change to a stop sign, like a spot of blue paint, can result in the AI method missing the sign entirely. An AI method that is repeatedly fooled will not be trusted. Other real-world examples include pieces of tape on road signs, so autonomous cars think it's a different sign altogether. Stickers on a road causing Tesla Autopilot to change lanes into oncoming traffic. A 3D printed turtle with colorful shell patterns designed so that the turtle is misidentified as a rifle. And one of my favorites, colorful glasses that causes AI-based facial recognition to misidentify the wearer as Brad Pitt. And personally, for me, that would be a significant improvement. These examples are all for fun and deal with slight modifications to in the visual domain. But similar principles can be used in other data, such as sound, speech, and sonar, the electromagnetic spectrum, radio communications, and radar, in the IR and hyperspectral domains. Any domain in which AI is used can be manipulated to fool the AI method. We at R-DEX Systems developed countermeasures to manipulation, which we call validation of artificial intelligence technologies, or VAIT for short. VAIT was initially developed to protect the digital processing pipeline, the data streams coming in, the digital data, but has since been updated to include identifying physical countermeasures. Our Phase 2 effort will be ending soon. The capstone of our Phase 2 effort was a flight test using an Air Force high-performance processing pod, the Agile Condor, and a Navy synthetic aperture radar, SAR sensor developed under the TSET program. We are focusing on identifying physical countermeasures such as corner reflectors to confuse the scene, camouflage nets covering targets, and electronic countermeasures. Currently, we are analyzing the collected data to see how well we did. The big question is, if AI is so easily fooled, how can we trust the results? Through the remainder of my talk, I ask you to think about, where is AI used in your operations? How is the AI assured? And what would be the impact if the AI was being fooled? Would you even know? R-DEX Systems was formed in 2014 to bring cutting-edge technology to commercial and government customers. R-DEX has two divisions, a robotics and industrial automation division and a military and defense division. The military and defense division has two branches, artificial intelligence and image exploitation branch, and a signals and cognitive technologies branch. We are a growing company located in Woodstock, Georgia. We service a strong and diversified customer base that includes every military service and other military agencies, such as DARPA. R-DEX has a long history of SBI successes, some of which are listed on the right. I won't go over all of them in detail, but I did want to highlight 3 recent awards. First, the Air Force Weapons Pitch, where R-DEX successfully pitched improved target classification AI/ML software that detects and identifies countermeasures against missile radar seekers in real time and strengthens the radar against them. Secondly, R-DEX won the Army Waveform Challenge, generating a direct Phase 2 award for our idea to use the Mercury Systems Rapid Spectrum Processing Platform. This project is exciting in that it is to implement and demonstrate the ability to program once and seamlessly deploy on different vendor SDR platforms, eliminating vendor lock. Third, there's Blue Jay, strengthening SIGINT classifiers and identifying adversarial attacks with the goals of identifying when someone is trying to fool a SIGINT classifier, addressing a major warfighter complaint that when current AI platforms are updated, they forget what they had learned. So we're researching learning without forgetting and continuous learning paradigms for this application. And finally, to hide communication signals by fooling opponent classifiers. So the idea here is you have a communication waveform, maybe it's FM, and what you want to do is perturb it, apply an adversarial attack to it, so an opponent's classifier views that FM waveform as an AM, say as an AM waveform, thereby hiding the communications from an opponent's classifier. This is a phase 2 that started February 2022. This SBI effort was developed out of the solicitation N193-A01, focus area number 5, counter AI, with the goal of developing innovative approaches such as complementary classifiers and meta-reasoners to understand such failure modes, propose mitigation plans to prevent the deceit of AI/ML algorithms leading to resilient systems. Such solutions enhance AI/ML techniques' capabilities, delivering results that can be trusted, validated, and on par with human-like performance. To review, we are seeing an explosion of AI being used to help with time-critical decision-making applications in the military and commercial sectors. And as I mentioned earlier, simple adversarial attacks to AI inputs can fool these systems into making life-threatening errors. We also know that these attacks can be both man-made and natural in origin. It doesn't matter as long as it negatively affects the AI system. However, the man-made attacks are being weaponized against a wide range of targets. To combat this increase in attacks, R-DEX Systems has developed VAIT to detect, classify, and adapt to adversarial attacks in both the imagery and signals domain. VAIT can be adapted to protect and defend ground, airborne, and satellite-based sensor systems. VAIT consists of a family of adversarial input detector, or AID, models for the detection and classification of adversarial inputs, as well as methods for prediction correction. It is attack agnostic. The underlying approach holds for a variety of deception techniques, such as jamming and spoofing of electronic attacks, or camouflage, concealment, and electronic deception of imagery domains. These models were developed through a combination of SBIR and internal research and development efforts in an effort to defend AI usage in multiple theaters of engagement. Our models are unique in that they focus on how attacks disrupt the classification model, which in turn can help AI improve performance and increase human trust in the AI system to perform its tasks correctly. The current Phase 2 period of performance will end April 2022. As with our other SBIR efforts, we were able to rapidly mature VAIT to a software technology readiness level of 6. We performed a flight test with Air Force HPC processing pod, Agile Condor, and a Navy SAR sensor developed under the TSET program. We also improved classifiers for applications with limited training data, such as SAR and ISAR. And we have developed methods for systems to adapt in real time to adversarial countermeasures through the use of complementary classifiers. Complementary classifiers are multiple AI/ML methods, neural network architectures, to increase trust in classifier performance and training. We've trained classifiers with adversarial inputs so these classifiers would then identify adversarial data correctly. And importantly, we have integrated our VAIT with partner hardware and software platforms, as Agile Condor, the Air Force high-performance embedded computing system for airborne platforms, the government off-the-shelf Hydra platform managed by L3 Harris that is used by the intelligence community, and the Mercury Systems rapid spectrum processing platform. Now, once the system detects and classifies adversarial deception techniques, then the system can leverage that information to adapt in real time. This has significant advantages and benefits in a wide variety of warfare platforms, such as EW. They can now autonomously recognize when military waveforms experience an attack and adapt to counter that attack in real time. Signals intelligence systems can harden AI-based signal classifiers against spoofing and jamming and adapt in real time. Weapon systems, we have improved missile seeker classifiers for identifying targets that are employing countermeasures. And of course, fire control radar. One of our exciting projects was to improve bird drone discrimination. And so other ISR systems can improve target classification for targets with limited training data and those that are employing countermeasures. Our market analysis shows that AI is becoming ubiquitous for critical decision-making in a wide range of military and commercial applications. Adversarial attacks can be weaponized for a wide range of applications. Our analysis shows that 5 areas most immediately affected by adversarial attacks are content filters, military, law enforcement, human-based tasks being replaced by AI, and civil society. R-DEX Systems has developed a suite of technologies to detect, classify, and adapt to adversarial attacks in both the imagery and signals domains. In addition, we believe that an immediate opportunity for protection is information products that leverage data from emerging low-cost SAR satellite constellations, and that is a nascent and growing opportunity. At this stage of development with our VAIT SBIR, R-DEX is seeking interested transition partners. We see multiple potential transition paths that are of interest to both military and commercial customers, such as the Joint Artificial Intelligence Center, National Geospatial Intelligence Agency, the National Reconnaissance Office, and existing fielded partner classifier models. Commercial opportunities include information products that leverage satellite and airborne data for customers that have critical need to monitor human activity throughout the world. Critical financial services, physical and financial traders, government policymakers and analysts, the infrastructure industry, and any customer that uses AI to automate the curation of large amounts of data. The key takeaways in this presentation are AI gives amazing, superhuman results. But AI is everywhere. But AI is easily fooled. VAIT by R-DEX Systems is a suite of algorithms that detects when someone is trying to fool AI, adapts to counter the adversarial attack, improves performance and trust in the AI systems, improves robustness in AI systems, and addresses AI explainability. R-DEX is currently expanding VAIT to become a larger suite of quality assurance tools for AI ML to provide confidence in AI and ML results. Thank you for your undivided attention. Send me an email and let's talk about how VAIT can improve AI trust in your organization or command. Thank you again and have a great day.